So this video will be on chapter 12, number 11. It's a good overall kind of problem on the whole population growth thing and the difference between growth rates. And then number 12 is similar-ish, so if you can do number 11 well, you should be able to get number 12 done pretty well. Okay, so here's the idea. In Mexico, the population in 1987, which we'll call t equals 0 because it's a lot easier than using big numbers, is 82 million, and they say 2.5% growth rate, annual growth rate every year. And then the United States in 1987 is 244 million, 0.7% growth rate. So then the first question is, when will Mexico have 164 million people? Okay, so first off, we can do the numbers without the millions. We can just do it in like 82, and we know we're talking about millions. 244, we know we're talking about millions. Putting in all those zeros is just a hassle, and we just have to remember we're dealing with millions. So that's one thing. Now, the other tricky part is, when they say 2.5% growth rate, does that mean at the end of the year there are 2.5% more people? So if you start off with 100 million, you'd have 102.5 million. Or is that a continuous growth rate, which, like we talked about before, getting interest on the interest, you have growth on the growth, and so it ends up being at the end of the year you have like maybe 103 million. And that's, they don't really say. If it is a continuous growth rate, then you would use the formula, put it this way. If it was continuous growth rate, you'd use the formula that the population was the initial population, e to the RT, where r is the growth rate, which is 2.5%, but you always do math with decimals, so it would be 0.025. And you'd use this formula. If it was instead 2.5% more people at the end of the year, then you'd use the formula where basically you're compounding only once. And it's the formula where you have 1 plus the rate divided by the number of times they're compounding to the nt power. And you'd use that formula with n equal 1. If n equals 1, that, oops, and I forgot the p0 there. With n equal 1, it boils down to p0, 1 plus the rate, which would be 0.025 to the t power, which is very simply that the population is p0 1.025 times 1.025 to the t power. So it always ends up that way. You either use this formula where the rate is continuous and you just plug in the rate as 0.025 to the e to the rt, or you have 1 plus the rate to the t power. And that's like, the p0b to the t, where b is always 1 plus the rate. So which one do you use? Do you have 2.5% more at the end of the year, or is it a continuous 2.5% growth, which means you have a little bit more than 2.5%? And really, I don't know. I did it both ways to make sure, and you get the same answers. It's not that big of a difference. My feeling is that they meant, and normally this is what people mean, is that at the end of the year you have 2.5% more people. That's normally what you'd think about. But either one will get you the answer they have in the back of the book. But that's what makes more sense. When you say 2.5% growth rate, you have 2.5% more people. So we'll use the formula P equals P0, the number you start with, times 1 point the growth rate, 0.025, to the t power. That's, I think, more what they mean. At the end of the year, you have 2.5% more people. Okay, so we want to know when it will be double. So our P0 is 82 million, so when will there be 164 million? So 164 is equal to 82, 1.025 to the t. Put the 82 over here, you get 2. So 2 is equal to 1.025 to the t power. Let's see, we want t, and it's in the exponent. The way we get that down is take the natural log, or any log, but I always like natural log. The log of both sides. ln of 2 is equal to ln of 1.025 to the t. And when you take the natural log, or any log, of a base to a power, you can put the power in front. So, showing all my work, ln of 2 is equal to t times the ln of 1.025, or finally the time is ln of 2 divided by ln of 1.025, and now you plug that into a calculator, divided by 1.025 ln, and I get in about 28, it's 28.07, but we'll just round off to years, so in about 28 years. So it's 1987, so 1987 plus 28, that's always tricky math. Let's see, that would be 13, so 2015. So in 2015, if things continue the way they're growing, if it stays at 2.5% growth rate, Mexico will have 164 million people, double the population, which of course by now that's in our past. Okay, that's A. Now let's look at B. B says, when will the United States and Mexico have the same population? So Mexico's population is growing, and if it should catch up eventually. Okay, so first we need a formula for the United States. So for the United States, the population is the initial population, which they said 244 million, and a 0.7% growth rate. So it would be 0.7%, 0.007. We always have to use decimals here, so that looks right. So we'll go with 0.007, so 1.007 to the t. That's the United States population. And we want to know when that's equal to the Mexico population. So we set that equal to the formula we already have for Mexico. So populations are the same, which is 82 million, that's their P0, but their growth rate is 1.025 to the t. Okay, so that's what we're solving here. This thing here, Mexico, the United States starting at 244, growing at 1.007 to the t equals Mexico starts a lot less but has a bigger growth rate. At what time are those two things going to be the same? Okay, let's get all the t's on one side and the other numbers on the other side. So I have 1.007 to the t divided by 1.025 to the t equals, let's see, put the 244 over here, 82 divided by 244. This is, since they're both raised to t power, we can write it like 1.007 over 1.025 to the t equals, and I'm just going to do that math now, 82 divided by 244. I get 0.3360, so 0.3366 is probably good enough. Let's see, we want to get that t down because that's what we're solving for. We know the way we do that is we take the natural log of both sides, or again, you can take log base 10 too, but take the natural log of both sides, that brings the t in front. So on this side we have, and let's, this side we have t ln of 1.007 divided by 1.025 equals the ln of 0.336. Or finally, I'm going to go up here to finish it, we have t is equal to the ln of 0.336 divided by the natural log of 1.007 divided by 1.025. Now it's a calculator problem, so let me do that. That's ln, I get negative 1.09 on the top divided by, let's see, 1.007 divided by 1.025 divided by negative 0.0177. And you really should keep lots of decimal places. I think that's good enough. 1 over times 1.09. And I get 61.5 years roughly. 61.5 years. Notice the negatives cancel, which is good. The math works out. So, and then it makes sense. It's going to be a long time, right? Mexico's got to catch up all the way from 82 million to 244 million and more than that because the United States is growing also. So 61.5 years, sure, that sounds about right. So what year is that? It's starting in 1987, so the year is 1987 plus 61.5, which is, and I don't feel like doing this in my head, I get 2048 and a half. So yeah, so 2048 and maybe halfway through the year. Which is, I think, the answer that they get too. So, hooray, the book did it right. Good for them. All right, so that's the basic idea. The tricky part here is, again, figuring out what they mean by growth rates. And again, here I think they mean at the end of the year you have 25% more, which means use this formula, not the E to the RT formula. But if you had done the other way, I think it would have gotten you about the same answer. As long as the growth rates are small, it doesn't make that big a difference. Okay, hope that helps.